The aim of this video is to use partial fractions to solve integrals. Before watching this video, it's important to make sure you're familiar with partial fractions as a standalone technique, as it's pretty much going to be taken for granted here. And when to use this technique. So if the integrand is a fraction and the bottom can be factorized, try using partial fractions. So example 1. The integral of 4x minus 9 over x squared minus 5x plus 6 dx. The bottom of this can be factorized and written as x minus 3 times x minus 2 dx. As it's factorizable, it fits the criteria stated above, so we should have a go at rewriting the integrand. So this part here, by using partial fractions. So in this case, as there are no repeated factors on the bottom, we can write this as a over x minus 3 plus b over x minus 2. If you multiply both sides by x minus 3 and x minus 2, we get 4x minus 9 equals a times x minus 2 plus b times x minus 3. I will let x equal 2. 8 minus 9 is equal to b times minus 1. We've got 2 minus 3 inside the bracket there. Minus 1 equals minus b, therefore b must be 1. You should always do something in your work to draw attention to that, because it's quite easy to then lose that information amongst your work. And then let x equal 3. So 4x would become 12 minus 9 equals a times 1, and there are no b's, so we get 3 is equal to a. So we can rewrite the integrand as 3 over x minus 3 plus 1 over x minus 2 dx. These follow the k f dash x over f of x pattern discussed in the first video. So both follow the k f dash x over f x dx pattern in video 1. So when integrated, they become 3 ln of x minus 3 plus ln x minus 2 plus c. Okay, let's move on to example 2. 5x squared minus 6x minus 21 all over x minus 4 squared times by 2x minus 3 dx. So the denominator is already factorized here, so it's very likely partial fractions will be useful. So we should try to rewrite the integrand by using partial fractions. So a would be over x minus 4 squared, b over x minus 4, and c over the remaining factor 2x minus 3. This is the case of partial fractions where there's a repeated factor on the bottom. Multiply both sides by the denominator to get a times by 2x minus 3 plus b times x minus 4 2x minus 3 plus c times by x minus 4 squared. Let x equal 4. So 5x squared becomes 80 minus 6 times 4 minus 24 minus 21 is equal to a multiplied by 8 minus 3, 2 times 4, 8. Then that's 35 is equal to a times 5, therefore a is equal to 7. And then we need to find b and c as well, so let x equal 3 over 2. So 5 times x squared in that case is 11.25. Then minus 9, 6 times 3 over 2, minus 21 is equal to 6.25 c. Therefore c is equal to 3. And then finally we've used all of the sort of sensible values of x that wipe out most of the right side of the equation and allow us to find a, b or c separately. So now we just use an easy to use value of x. So we'll let x equal 0. So the right becomes minus 21 and a multiplied by minus 3 plus b multiplied by minus 4 multiplied by minus 3 plus c times minus 4 squared. Plugging in what we know, a is 7, so that's minus 21. We don't know b, so we've got 12b minus 4 times minus 3, and then plus 16c. c was 3, so that's 48. Minus 21's on both sides cancel, leaving minus 48 is equal to 12b. Therefore b is equal to 4. Okay, so we've got a, b and c. We can assemble the partial fractions form of the integral. So that's 7 over x minus 4 squared minus 4, b should have been minus 4, minus 4 over x minus 4 plus 3 over 2x minus 3, all integrated with respect to x. Now the last two here are simple. So simple cases of k f dash x over f of x dx. But the leading one requires us to use the substitutions dealt with in video 2. Use the u substitution from video 2 in this series. So we would let u equal x minus 4, du dx would be 1, so du can replace dx, So we'd rewrite as 7 over u squared du. We'll bring down the rest of this, just taking the minus 4 out of the integral, and then the other part taking the 3 out. So 7 over u squared is the same as 7u to the minus 2. When we integrate that, we get 7u to the minus 1 over minus 1. The next part of the integral is minus 4 times ln x minus 4. The part after, we have to be careful with this. You can rewrite the top of the fraction as 1/2 times 2. Because we do this because the derivative of the bottom there, the derivative of 2x minus 3 is 2. So we can use the k f dash x over f of x pattern. So 3 times 1/2 ln 2x minus 3 plus c, and then this just needs to be tidied. So at first we've got 7 over u minus 4 ln x, ln of x minus 4 plus 3 over 2 ln 2x of 2x minus 3 plus c. Okay.